Hello everyone. I was planning to go over this in class today, and since we aren't having class today, I thought I would make a little video discussing um, the answers to these questions. So this is the sheet that I gave you in class. Remember 007 would be uh, the bonding questions. All right, number one. Which element in ClO attracts electrons most? You remember that electronegativity increases on the periodic table as you move up and to the right. So since if you're looking at, generally you expect the one further up to the right would be more electronegative. If you look at the periodic table, you got oxygen here, you got Cl down here. So you're going up and to the right. It's a little bit hard to tell which one is going to be more electronegative. So you're going to need to know that since chlorine has another energy level, uh, it's a little bit less electronegative than oxygen is. Basically, oxygen is the second most electronegative element on the periodic table, next to fluorine, which sits right here. Then you have nitrogen, which is similar to chlorine. They're kind of the same. So, but as you go this way, electronegativity increases, and nitrogen actually trumps chlorine a little bit because of that energy level. So the answer here would be oxygen. So that's E. The most probable formula of an alkaline metal, remember alkaline metals have, that's the first column, and they have one electron in their outer shell, so it'd be a +1 charge. Oxygen has a -2 because it's got 6 electrons in its outer shell, so it'd be X2O, or X2Y, so that'd be B. Elements that gain electrons, they gain electrons, they have negative oxidation states because electrons are negative. Which is strongest? That would be, you might think it's polar bears, but actually probably it's bonds between ions, especially given this, in terms of strength per relative size. So that'd be A. Bonds between molecules are weak bonds. Remember, the strongest of them is a hydrogen bond, but even that's 10 times weaker than your basic covalent bond. Atoms that attract shared electrons, if they attract them a lot, they have a high electronegativity. So electronegativity means attraction for electrons. The higher melting point, if they're a similar size, would be polar molecules, because polar things stick together better than nonpolar things if the size of the molecule is similar. Remember, when we talk about big nonpolar molecules, they can stick together as well as a polar molecule is a bit smaller. But given similar size, polar molecules stick to each other better. Matter of this kind of bonding would tend to dissolve in water. Remember, water is polar, so we'd expect polar bonds to dissolve in water, so that'd be D. Sometimes ionic things dissolve in water too. Often ionic things dissolve in water. So just a real quick note about that. If you have KCl +1 -1, and if you had Al2O3 +3 -2, which one of those would be more likely to dissolve in water? That would be the KCl, because the KCl ions don't have as high a charge. They're not as attracted to each other as the aluminum oxide ions are. So aluminum oxide, the things with higher charge tend to be insoluble in water, and things with lower charge that are ionic tend to be soluble. That doesn't always hold true, but that's a generalization. Okay, bonding created by sharing electrons between two atoms. That's covalent. If it's like thousands of atoms and the electrons are, you can't even say that. Just if they're between two atoms, it's covalent. So that's C. Which of the following atoms tends to gain electrons? Gaining electrons would be a nonmetal. All of these are metal, so that'd be E. None of those. Number 10, bonding that involves positive and negative attraction between ions, that's ionic bonding. Number 11, a chemical bond is considered to be primarily ionic if atoms of an active metal combine with an active nonmetal. That's because ionic bonds involve a transfer of electrons, so you have to have a Something to take the electrons, that'd be the active nonmetal. Something that wants to gain electrons. And something to lose electrons, that'd be the active metal. Something that loses electrons easily. So the answer would be B. Most ionic would be the ones that are furthest apart on the periodic table, because once again, you're looking at active metal, active nonmetal. So you look at the periodic table, K is over here, Cl is over here. Those are the furthest ones apart. Iodine's down here. Bromine's in between them, in between the bromine and the iodine, that is. And sulfur's over here. Of course, so obviously the ones that are furthest apart are K and Cl. So that's A. 13, the bond between the chlorine and chlorine is nonpolar. And that's because the electrons are being shared equally. Not unequally, but equally. Nonpolar covalent. A molecule is polar. Polar means having a positive and negative pole, like in HCl. If you haven't, there's a dot diagram for HCl. But in reality, the electrons are spread. Excuse me. The electrons are spread over here. So I have a little glitch like I normally have with this thing. So if electrons, okay, so the electrons in the electron cloud, they tend to be lopsided on this side, making this end partially negative and this end partially positive. All right, so it's polar if it has unequal sharing of electrons. That's B. A nonpolar molecule would be even sharing of electrons. Nonpolar, uneven sharing. Molecule that is not attracted to water would be the best answer there, because transfer of electrons is ionic. No sharing of electrons is is ionic. Uneven, and also neither one of these would be a molecule. Remember, molecules imply covalent bonding. Uneven sharing of electrons is polar. So the best answer is D, because water is polar. Non-polar molecules will not be attracted to it. Remember we talked about oxygen dissolving in water. It doesn't work very well because oxygen is non-polar and water is polar. Okay, now when you get to these kind of questions, you're going to need to draw dot diagrams. So which of the following molecules is polar? You do NH3, looks like this. The H is down here. So is that going to be polar? Yes. H2O looks like that. Is that polar? Yes. N2 is not polar. PCl3 is going to have, I'm going to assume you remember how to draw dot diagrams, so I'm not taking time to go through all the logic here, but that's a pyramid. Don't know why I have that up here, but we'll just leave that up there. Anyways, that's a pyramid. So the answer is more than one of those. Oh, there we go. So the answer is E. So all three of these would be polar. The only one that's not polar there is the nitrogen. So the answer is E. All right, can a molecule with only polar bonds be a nonpolar molecule? The answer is yes. Here's an example. Carbon dioxide has polar bonds, two polar bonds, but since the vectors move in this direction and in that direction, they cancel each other, so the molecule is nonpolar. Which of the following elements will never be in the center? It'd be the one that's the most electronegative element will never be in the center. That's fluorine. That's D. Because fluorine is the most electronegative of all these elements. Covalent bonds usually form between what? Two nonmetals. Which of the following contains nonpolar covalent bonds? Nonpolar covalent bonds. You know, this would have H to Cl, that's polar. This is H to O, that's polar. This is N to H. So none of those have nonpolar covalent. Resonance is when there's more than one place to put a potential double bond. You need to draw the dot diagrams. When you do, you'll find this is a double bond in sulfur dioxide. And that double bond could have been on either side, so that's resonance. When there's more than one place to draw the double bond, it's resonance. Which one has 5 pairs or 5 domains around the center? That would be the trigonal bipyramidal. Which of the following compounds would most likely be insoluble? Okay, now these, remember we talked about ionic things attracted to water molecules, and we said the things that have the higher charge tend to be insoluble. So which one would that be? That'd be D, because Mg is +2 and O is -1. Excuse me, O is -2. So +2 -2, but this is +1 -1, +1 -1, +1 -1, +1 -1. So D is the only one that has the higher charge. And the thing that really drives, you remember the Born-Haber cycle, the thing that really drives, that is, releases energy, which following that natural trend in the universe toward lower energy, the most significant factor is the lattice energy. Gaining electrons releases energy, but not as much energy is released by gaining an electron as from the lattice energy. So D. So which of these pairs will have nitrogen in a positive oxidation state? Nitrogen would have to bond with something more electronegative than it is. There are only 2 elements more electronegative than nitrogen, and they are fluorine and oxygen. So if nitrogen bonds with fluorine, or if nitrogen bonds with oxygen, nitrogen will be positive. Hydrogen bonding. Hydrogen bonding exists between molecules when hydrogen exists within a molecule attached to a highly electronegative element. So if there's 2 hydrogen fluoride molecules, the hydrogen bond will be right here between those 2 atoms. So the hydrogen bond goes between these 2 atoms right there. There's not a literal bond there, it's just a positive negative attraction. But it only happens, hydrogen bonding that is, only happens when hydrogen is bonded to N, F, or O inside a molecule. And so you see the only place that's set up is letter D. Pi bond forms from unhybridized p orbitals. Remember the sigma bond is between on a straight line, and the pi bond comes from these p orbitals that overlap here and here. So that's B. Which of the following molecules will contain 2 pi bonds? To have 2 pi bonds, you'd either have to have a triple bond or 2 double bonds. So when you draw the dot diagrams, you'll find that letter A has 2 double bonds. So sp3 involves blending blank atomic orbitals into new orbitals of equivalent energy, and S and 3 p's makes 4 orbitals. So you just basically count them up. 1, 2, 3, 4. And that's the kind of bonding that's most common, or kind of hybridization, I should say, that's most common. The highest boiling point, from these molecules, which are all nonpolar. Now you'd have to draw the dot diagrams to know they're all nonpolar. If they're all nonpolar, would it be the bigger one or the smaller one that would have the higher boiling point? Of course, having a higher boiling point means the molecules are going to stick together more. So the bigger one, so that's C, is the biggest molecule there, because iodine is the biggest element to go with the carbon. Down here, which has a higher boiling point? That one's a little bit polar. That one's polar. That one's polar. But the most polar and having hydrogen bonds would be letter D. Most likely be insoluble in water, be the ones with the higher charge. So which one is that? Hopefully you said C, because you got +1 -1, +1 -2 for carbonate, +3 -3, +1 -1. And here, which one's most likely insoluble in water? Well, SeO2 would have a bent molecule when you actually draw the dot diagram with resonance. HF is hydrogen bonding, so that's not going to be insoluble. CO is going to be that, but it's going to be polar. So that leaves XeF4. XeF4 looks like this. has four extras, so two pairs extra. That is a pair of electrons above the xenon and a pair of electrons below it. So that's going to be a square planar molecule. So a square planar for XeF4. And so that makes it nonpolar because all these vectors are going to cancel. So the nonpolar one is the one that's going to be insoluble. Okay, so I thought you need to know that. Remember, for this final, you need to know the this. You need to know that the atoms and periodic trends that I gave you in class. I gave you a multiple choice on that. We went over that one in class, and then you need to be able to draw dot diagrams. So the final will consist of just basically a unit test going from atoms to the end. Hope that helped. Email me if you have questions.